Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, Colorado, and this afternoon we're at the CoolIT Systems booth with the CEO, Geoff Lyon. Jeff, welcome to Denver. Why don't we start at the beginning, though, for folks that might not know, who is CoolIT Systems and who do you help?
Sure, Rich. Well, CoolIT Systems specializes in creating high-efficiency, direct contact cold plate technology so that server implementations like what is all around this floor, high performance, high heat, high density, can be managed more easily with liquid cooling.
Okay. Well, can we kind of do a booth tour? Because you've got a lot of equipment here and a lot of interest.
Absolutely. We've got some exciting stuff that we're showing here for the first time. We did announce this one at the last show. We've now got a well-developed partnership with Dell EMC. What's on display here is the factory-integrated C6420, and that's a high-performance server blade that goes into a 2U4 node configuration. And it is allowing Dell to promote a much higher density rack overall with the highest SKU high-powered processors.
Yeah, these new ones are something like 300 watts, some of these P100s and things. Yeah.
That's right, 300, and some are even higher.
Wow.
So we're liking the trend because it really showcases what we can offer. Next, we have a new system that we just did an announcement on, that we did this one for Intel, and this is a Buchanan Pass. It's been optimized with liquid cooling. It's an exciting, very involved development with liquid cooling not only on the CPUs, but also actually for the RAM. So this is a rather elegant solution that allowed all of the components to be individually serviced. So there's even a tool that, if it's necessary, so that you can, in some cases, you need to replace a DIMM, and you don't want to have to take the entire cooling system off just to service a DIMM. So now we have the ability with this tool to pop out any one of the RAM DIMMs without doing anything in the cooling system. And then, let's say this one was faulty, then you would have the ability to then place it back in. Piece of cake. With the flexible tubing, you can take off one of the CPUs or roll the other one out of the way, so even the CPUs could be changed and serviced if necessary. This is an exciting case study that we just finished. We did a great installation in cooperation with the Chime project. So Chime is a Canadian hydrogen intensity mapping experiment. What that is, it's a large radio telescope. It's an exciting project because they had some unique requirements. They had a full rack system that was contained inside a shipping container. They couldn't have any compressive cycles, no DX, no air conditioning at all. So what we did with this is we actually have a liquid-to-air heat exchanger. Basically, it's a radiator, but instead of dissipating heat as a radiator, it's actually absorbing heat, so that warm air from the container will go through the box, be cooled off for the rest of the components inside, or the low-density heat components inside the box. We then liquid cool the CPU, and as well as both dual GPU systems that are AMD Fire Pro. Here we have examples of our cooperation with HPE. There's a high-frequency trading system here that's been optimized. Effectively, it's like an overclock server. But it's a self-contained loop, so that it has the same sort of logistical treatment as a regular server that would be air-cooled. It's just got a slightly better heat sink by utilizing the liquid cooling module.
Yeah, so when we overclock things, they tend to become unstable if you can't take that heat away, right? So that's important that you can do this.
You got it. So it adds the ability to have slightly higher frequency more of the time, and that's important to the high-frequency trading space. The other side is an example of integration on an Apollo 2000. So we do these on a case-by-case basis when customers are requesting it, so that they too can increase the density of the overall installation in the rack. So this is actually quite an interesting little box. We built it so that our OEM partners can actually burn in the servers that are liquid cooled. In a normal process. They would put the server together, assemble it all with the air cooling, then they of course have to power it up, turn it on, and make sure it works before they go deliver it to the customer. When it's liquid cooled, they need something to plug them into in order to supply cooling to the CPUs or whatever happen to be integrated. Now what this does is it allows these are ruggedized little heat exchangers so that it plugs in, and then you can actually connect 4 nodes at a time, do the burn-in without any large investment to infrastructure in their factory settings. It also makes a great lab unit, and we've had a lot of customers wanting to utilize it for proof of concepts, testing, benchmarking, and that sort of thing. So it's been a nice little project for us.
Okay, cool.
Yeah, so this you know, the opposite end of the scale. This is our large row-based cooling unit. It's a CDU, and this supplies centralized pumping support for our coolant to go to all of the rack manifolds. This becomes a practical option when you have more than, say, 5 or 6 racks. This could handle up to, well, depending on the density of each rack, about 700 nodes.
How many kilowatts is that, roughly?
Well, it depends on the kilowatt load in each node, but the capacity inside here is up to about 650 kilowatts.
What do we got here, Jeff?
This is our flagship in-rack CDU. We call it our CHX80. It has a heat capacity of about 80 kilowatts, and that's 80 kilowatts of just the liquid absorbed heat. So in almost all of our configurations, we call it a hybrid direct contact liquid cooling. So we take 60, 70, maybe 80, or even as high as 85% of the heat inside the server and absorb it into the liquid and then whisk it away that way. That still remains a fairly high percentage of heat, and especially in these very dense configurations that needs air cooling. So let's say we grab 80%, this would be in a position to cool a 100 kilowatt rack, taking 80% in water at 80 kilowatts, leaving 20 kilowatts to be air cooled. That makes a nice dovetail for our partners with STULZ, and we'll see a combined product that we did in a little bit, but it has turned into a great value proposition for our customers.
Okay, Jeff, what do we have here?
So this is a newly launched product. We call it the AHX10, and it's a slight evolution from what we had previously, and the AHX stands for air heat exchanger. So in a lot of instances, we have customers that want to do a proof of concept. They want to install it in a rack, but they don't have facility water available. But they would still like to use the liquid-cooled version of the servers. So you put this into the rack. It actually mounts directly in the rack. It has a couple of options that are available. So if you would only need maybe 5 or 6 kilowatts of capacity, then it would be only 5U high. This is optioned up to allow more airflow. So it's basically got a hood scoop on the top and one on the bottom, which increases the amount of air that can go through the heat exchanger. And that gives us up to about 10 kilowatts. So inside this box is a liquid-to-air heat exchanger, N+1 redundant pumping, a full instrumentation so that you can tell exactly what the water temperature, pressure, flow, all being reported through our standard control system.
Is that accessible over the network so an admin could see what was going on cooling-wise?
Absolutely.
Wow.
Yeah, in fact, actually, let's have a look at that.
So, Jeff, is this the interface we were talking about?
That's right. So this is a duplication of what you would see on the front of any of our heat exchanger products. So it has detailed information that you might want to have for configuration or settings or even just checking how it's doing. So it features an overview that'll tell you how many pumps are running, what percentage of their capacity they're running at, what your flow is, the temperatures of the primary and secondary, the temperatures of the inlet and outlet, so it can even calculate how much heat it's dissipating. Inside here, you can get even more detailed information on what's going on with primary, secondary. With the controls, you have a couple of different modes. Like when we're talking about, this is actually for the CHX80, you have the ability for it to just run on default. And in default mode, it's autonomous,
Yes.
lights out. So it'll automatically guarantee that you're not going to go below dew point and have condensation inside the server rack. It'll also ensure that there's only appropriate amounts of flow, right? So it monitors the pressure of the outlet compared to the inlet, right? So as an example, if we didn't have that and the pumps are going 100%, and I then disconnect all the servers on one of the manifolds, well then it's going to be trying to push twice as much flow through the remaining connections, which isn't necessary. It takes up way too much power. It's actually hard on the pumps. So what this does is it monitors exactly how much differential pressure there is, so that it'll notice that there's less space for the water to go and lower the pump capacity so that it keeps only the appropriate amount of flow no matter what you do.
All right, Geoff, what are we looking at here?
So we're displaying here at the show again. We did have this at ISC in Frankfurt. It's the first combined product between STULZ and CoolIT Systems. After we partnered together, we couldn't help but notice the complementary technology that we bring to bear. And we thought if we were able to actually put a fully contained data center in place, we could have the air handling taken care of, we could have the high density capacity that liquid cooling affords. And when we put the two things together, there was actually even some additional benefits that we could find. So we'll have a look inside here. It's nice that it has a unified control system as well. There's full status information on your air temperature, the operating condition of the air handler, and it's actually a DX unit that's inside here. If we have a look inside, you notice this is fully sealed, it's gasketed, so that when this closes up, there's no air that comes out or no air that needs to go in.
No air at all.
Well, there's the air that's inside,
but
but it's just effectively going in a circle. So this unit here supplies cool air out to the front. The servers will consume that cool air for the air cooling capacity that's required. Well, in this particular unit, it's a DX unit, so it actually has a condenser, and we have facility water coming in to water cool that condenser. Then the exhaust liquid that comes out of that cycle is what we consume then to cool the direct contact. So even though we could have water coming in at 30 degrees Celsius and then it comes out at 35 or even 38 degrees Celsius, that's no problem for our system since we're doing direct contact liquid. We can accept water all the way up to 45 degrees and keep our direct contact processors perfectly healthy. So we add even more efficiency when we take that exhaust water, raise its temperature even higher, which means that when it returns to the facility, it can then be actually cooled even more efficiently.
Okay, Geoff, here we are at behind the micro data center. What are we looking at?
Yeah, just to kind of repeat what we were talking about in the front, we have the liquid cooling connections all built into this mechanical design. And then the hot air that's delivered back from the servers gets brought into the air conditioner and then keeps, again, the whole thing self-contained. As long as you can get the power in, then this can be a very healthy, very compact, very dense implementation.
Well, to wrap up, Geoff, we've been talking about liquid cooling for a long time here in HPC space. What are you seeing out there? What are you hearing from customers?
Well, like we announced yesterday, we've had the largest order we've ever seen. One customer, one deployment, over 200 racks, 30,000 cold plate systems. So we're excited about the migration that's taking place. People are not afraid of liquid cooling anymore. We have great benefits that can be brought to bear with efficiency, with higher density, and even with higher performance with these very high-powered chips. So the things that we've been talking about for years are now finally starting to come true.
It's kind of exciting to watch this, and I really want to thank you for having us here at SC17.
Always a pleasure, Rich. Thanks for coming.